Okay, now let us proceed with the example for half-range series. So this is the question from quiz 6C, question number 2. So the question is to find the half-range sine series. So you have to find the half-range sine series given the function fx is equals to x. And the interval is between 0 up to pi. And then you have to show that the series is equals to pi over 4. So first of all, you need to find the period. So since this involve half range, so this means that this interval 0 up to pi is half of the period of 2L. So we can know that L is equals to pi because the difference between these two is pi minus 0, which is equals to pi, where pi is equals to L. Okay, so the next one is you need to find the Fourier coefficient to get the Fourier series. Okay, another hint that we have here is to find the half-range sine series. So this means that we just need to find the coefficient of Bn because this is half-range of sine series. So using Bn, we can use this Fourier sine series expansion where Bn is equals to 2 over L times the integration of 0 up to L fx sine n pi x over L, which is pi dx. So this will be 2 over pi 0 up to pi fx is equals to x sine nx dx. So it's easier for us to use the tabular method. So first you have to know the symbol and then the function to differentiate with respect to x, and the third one is the function to integrate with respect to x. Okay, so for this case, the differentiation function is x and integrate is sine of nx. So the first symbol is positive, and then the second symbol will be negative, and differentiate x with respect to x, we get 1, and integrate sine nx with respect to x, we will get negative cos nx over n. Okay, so all this will be over n, and the last one is symbol will be plus. Differentiate 1 with respect to x, you will get 0, and differentiate negative cos nx over n, you will get negative sine of nx over n. Okay, now we already solved the integration, so we rewrite this as Bn is equals to x over n cos nx times negative, and then the second one will be negative times 1 times negative sine nx, so you will get plus sine of nx over n, where the limit is from 0 up to pi, and then Bn here must be times with 2 over pi. Okay, then we substitute x, with pi and 0, so you get negative pi over n cos n pi plus sine n pi over n, and then substitute x with 0, so minus is will be, the first part will be 0 and the second part will be sine 0 over n, which also will be 0, and this sine n pi also will be 0. So this will become negative 2 over n cos of n pi, or we can rewrite this as 2 over n negative 1 to the power of n. Okay, then we have solved bx. Now we can substitute into the function of fx. So to get fx, now we want to find the Fourier series, sine series expansion. So fx is equals to the summation of bn sine n pi x over pi. So we get sine of nx, where n start from 1 up to infinity. So we expand the summation, we get b1 sine of x plus b2 sine 2x, b3 sine 3x, b4 sine 4x, and so on. And then we substitute the coefficient of b1, b2, b3, and b4 using the coefficient of bn that we obtained before, where bn is equals to negative 2 over n times with negative 1 to the power of n. So when n equals to 1, we substitute into this, you will get the value is positive, so it will be 2 over 1 sine of x plus when b is equals to b, when n is equals to 2, so you will get negative 2 over 2 sine 2x, and then when n equals to 3 means that the value will be positive, so 2 over 3 sine 3x, and then when n is odd, so you will get negative of 2 over 4 sine 4x. So now we can write this in general forms in order to represent the series. So if you see here, the constant is 2. So we can take out 2 outside. So 2 times with the summation of, so the remaining is this fraction. So you will get 1 over n, okay, where n is start from 1, 2, 3, and 4. So you settle that one. Okay, the next one is sine. So it is increasing with the difference of 1. So 1, 2, 3, 4. So we can write as sine nx. Okay, and the last one is you need to identify the symbol. So the symbol start from positive and then negative, positive, and then negative. So this can be represented as negative 1. So when n is equals to 1, the symbol should be positive. So when n, so it must be add with 1. So that when n equals to 1, you substitute n equals to 1, you will get 1 plus 1, which will be positive 1. So that is why we have to power negative 1 with n plus 1. Okay, and then we rewrite it back. We get negative 1 to the power of n plus 1 over n sine of nx, where n start from 1 up until infinity. So this is the Fourier sine series expansion. Okay, the next question is to show that the series is equals to pi over 4. okay, using the Fourier series expansion that you obtained before. Okay, so the first thing that is very important to solve this question is that you have to choose the correct x, okay, in order to get into this series. Okay, so let's say we choose x is equals to 0. When you substitute x equals to 0, you will get sine and x will be equals to 0. So you cannot choose x is equals to 0. And also you cannot choose x is equals to pi, because when x is equals to pi, sine and pi is also equals to 0. So the best way is to choose something that has value of sine, okay, where we know that for this is pi, this will be 2 pi, 3 pi, and 4 pi. Okay, to get the value of sine, you have to choose x is equals to pi over 2, so that the value of sine will be equals to 1. And then we can get negative 1 for a certain n. Okay, so now let us try when x is equals to pi over 2. Okay, we substitute x with pi over 2, you will get f of pi over 2 is equals to 2 times with the summation of negative 1 n plus 1 over n sine of n pi over 2, where this function is equals to pi over 2 because the question given that the function is equals to x. So when x is equals to pi over 2, the function will be equals to pi over 2. Okay, now the next step is you have to expand this summation, where summation is n equals 1 to up to infinity. Okay, and then we bring these 2 to the right side. Okay, so the summation will be, first of all, we bring 2 to the other side, so we get pi over 2 divided by 2, which is pi over 4. So you can see that this has satisfied for the right hand side. So it means that choosing x equals to pi over 2 is the correct one so far. Okay, so let's see if we can get the series of 1 minus 1 over third plus 1/5 minus 1 over 7 plus and so on. Okay, now we expand this series. Okay, when n is equals to 1, you will get negative 1 to the power of 2 over 1 sine pi over 2 plus negative 1 to the power of 3 over 2 sine 2 pi over 2 plus sine 3 pi over 2. Okay, I need to expand this, so we will bring this to the side later. So negative 1 to the power of 5 times over 4 sine 4 pi over 2 where this is equals to pi over 4. So I expand this up until the denominator is equals to 7 to make sure that we can get the same as the question. Okay, now the next step is to substitute the value of sine. Okay, sine pi over 2 is equals to 1. And then when sine pi is equals to 0, and this will be equals to negative 1, sine 2 pi is equals to 0, so it will be alternate 1, 0, this will be negative 1. Okay, now we expand this, we get negative 1 to the power of 2, we get 1 times 1, which is 1, and then the second part is equals to 0. The third part is 1/3 times with negative 1, so we get 1 over 1/3, and then this one is equals to 0. Next is plus 1 over 5, negative 1 over 7, plus and so on, where this is equals to pi over 4. So it is shown that when you choose x is equals to pi over 2, the sum of the series will be equals to pi over 4. Okay, let's say you have to sketch the function of fx. Given that the interval that you need to sketch is from negative 3 pi to 3 pi. Okay, we know that the value of function is equals to x, not the value, the function is equals to x, where the interval is from 0 up to pi. So we can draw a straight line. So when x is equals to pi, fx will also be pi. So this y-axis is fx and x-axis is the value of x. Okay, so since the question asks you to find the half-range sine series, so this means that it is an odd extension. So for odd extension, it means that it is symmetry to the origin. Now we can plot the graph from negative pi to 0. Okay, we know that from 0 up to pi, the graph is like this. So it is symmetry to the origin. So it's just a straight line at here where the value of fx is equals to negative of pi. Okay, now we can repeat the same pattern for pi to 3 pi and for negative 3 pi to negative pi. So the pattern will be the same as just like this. So it just keep repeating the same with the same interval of 2 pi. Okay, so now we have done sketch the graph for the odd extension or for the Fourier sine series.